In the previous videos, I cleared a space for my garden room, discussed planning permission, and created a design. This 3D drawing was the extent of my design. I'd recommend downloading SketchUp. It's a free program and there are plenty of videos to help you get creating. I quite like to keep things fluid, so a rough sketch was all I needed. Everyone's different, so others will want to design down to the millimetre before they cut their first board. Either way, I highly recommend having at least a rough design in SketchUp done for estimating the amount of materials you'll need. My building's dimensions are 6.5 metres by 5 metres. However, it's definitely worth thinking about laying out your building in imperial rather than metric. In the UK, we seem to use both systems, and materials come in both. The build requires a lot of sheet materials, OSB, plywood, plasterboard, which come in 8 by 4 feet dimensions, which is a very awkward 2.44 times 1.22 metres. So for the majority of the build, I use feet and inches when laying out the floor and walls in order to avoid having to cut down sheet materials and to reduce wastage. If I were doing it again, I would probably use building dimensions in feet rather than in metres. And throughout the rest of this series, you'll see I flip between the two systems quite a lot, depending on what I'm measuring. The first task is laying out the building in the right location, at the right size, and getting it square. I had some long cedar lengths given to me by my neighbour, which I cut to the right lengths. 2 lengths at 6.5 metres and 2 5 metre lengths. Where I didn't have a length long enough, I screwed 2 pieces together. I located exactly where I wanted one corner, in my case at the boundary, and hammered a metal stake in place. From there I laid out the cedar to create a rough outline of the building. I then hammered in 2 more stakes at the 2 corners at right angles to the first and used a string line to connect them. I then measured the corner for a 90-degree right angle. There are 2 methods for doing this. The first is to hold up a folding square to the string. This is the simplest but least accurate method unless your building is very small. When folded out, it creates a perfect right angle triangle to compare your corner to. It's useful for getting the angle reasonably close before using the second method. The second is the 3-4-5 method. This uses Pythagoras Theorem, a squared plus b squared equals c squared. Remember that? A perfect right angle triangle is created by measuring 3 units along one string line and making a mark, then measuring 4 units along the other and making another mark. 3 squared equals 9 and 4 squared equals 16, the sum of which is 25, which equals c squared. The square root of 25 is 5, so therefore length c, the diagonal or hypotenuse, is 5 units if the corner is a perfect right angle. The units don't matter as long as they're all the same. You can use centimetres, inches, feet or metres. Obviously the longer the measurements, the more accurate the result. And the same works for 6, 8 and 10, which is useful if you're using feet. When the measurement was less than 5, I knew that one or both of the 2 stakes needed to be moved away, and if more than 5, then one or both needed to move closer to each other. It's quite satisfying when they all work out, and it's worth taking time over this to get it right. Once the 3 stakes were in the right place, I hammered in the 4th and then used the 3-4-5 method on that corner as well. Once this was done, I checked my work by measuring it across the 2 diagonals. If they were exactly the same length, then I knew that the building was completely square and all the corners were at right angles. This last method can also ensure that the building is the right size, again using Pythagoras. As my building is 6.5 metres by 5 metres, I knew that the diagonals should be 8.2 metres across. Once the building's dimensions were laid out, I could look at the different options for foundations. I'll run through a few of the ones I looked at. The first is the most complicated and expensive, but certainly the most solid. This is the method used in most house extensions. It involves pouring a concrete slab with the insulation within the foundations, removing the need for a wooden floor. The sides can be either poured separately or dense concrete blocks can be used. A raft foundation is similar, but is useful for sites on clay soil or near trees, as the foundation moves as one floating raft. Another option is a simple concrete slab for the wooden floor joist to sit on top. This is a pretty common method for sheds and garden rooms. Another common method is to use a post hole digger to sink wooden posts or metal brackets into the ground and to pour concrete around them to hold up the timber floor. However, the option I went for is the easiest and cheapest and doesn't require concrete to be poured at all. It involves piers spaced under the floor joist to hold the building up off the ground. There are a few specialised products on the market, such as these, but they are quite expensive and, in my opinion, not really necessary. I use 7 Newton per millimetre squared dense concrete blocks at £1.44 each. It's important to use the dense ones as the whole weight of the building goes through them. Another great advantage of using blocks is that the timber floor can be moved around on top of them, giving some flexibility if they are not perfectly in the right spot. When buying materials for the build, I avoided the likes of B&Q and Wickes, and instead used local builder and timber merchants, as they offer much better value. 2 great websites to check for prices are Selco and Builder Depot. To buy from Selco requires a member's card, so you need to have a business to get one, but they've now put up all their prices online, which is pretty useful when comparing against smaller merchants. Another tip is to buy the floor joists at the same time as the blocks, to use to help check the piers for level, which I'll show in a bit. The required number of piers and the span between them depends on the size of the building and the depth and the quality of the timber used in the floating floor. I'll go into detail on span tables in the next video, but this is something that you'll need to know before deciding how many piers your building needs. For mine, I used 12 piers spread out like this. I started my first pier in one corner, where I could roughly measure 15 centimetres, 6 inches, from the surrounding ground. This measurement is from building regs and lifts the floor a good amount off the ground so as not to be affected by splashes from rain and also to allow good airflow under the building. I transferred this using a stick and moved the string line up or down accordingly. The string line is where the top of the pier needs to come to, and it doesn't need to be exact, just somewhere near. I dug down far enough to reach firm, undisturbed soil. The blocks need to sit on at least 10 centimetres of compacted hardcore, which are small pieces of concrete from 40mm all the way down to dust. These interlock when compacted, creating a solid base. I had plenty from tearing up my garage floor, but it's not that expensive to buy. The first block should be sunk at least halfway into the ground, below ground level. As they're 100mm thick each, it's quite easy to work out where the first one needs to be so that the top one reaches the string line. Once the first pier was complete, I could use the top as a reference to get the others level. It's worth investing in a long, good quality spirit level. I compared against as many of the surrounding piers as possible. The timbers come in useful for this. I chose the straightest timber I had for best accuracy. Once all 12 were done, I lay down weed fabric to stop anything growing up and into my floor from below. It comes with plastic pegs to keep the fabric in place. My first mistake was not cementing the blocks together. After some more research, I realised this was an absolute must. As my site is on a slope, each pier has a different number of blocks, so to counter this, I used thick layers of mortar on piers with 3 blocks, and then thinner layers on those with 4 or 5 blocks. Again, I checked each one for level with the surrounding blocks. I'm no bricklayer, but the mix I used was 1 part cement to 4 parts sand. It's important to have sand without any stones in it for this. Once this was done, I also created a retaining wall at the back, as the alleyway behind is higher than under my building. So that's the layout and foundations done. In the next video I'll cover how I made the floor, insulating and covering it. Thanks so much to everyone who subscribed, and I'll see you next time.